This is gonna be the first video on this channel. It's gonna be about this entire genre of solving challenging problems from math competitions. Now, the specific problem is from the 2016 NSML contest for 11th graders. NSML is a league I participate in. It's hosted in Illinois every year. Let's just get started right away. What it says an NBA playoff series is a sequence of games between two teams that is best of 7. That is, the first team to win four games wins the series. There can be no ties for any game. According to NBA history, teams that have won 3 games and lost 1 game out of the first 4 have won the series 80% of the time, or they have won the series 65% of the time when they have lost the 5th game. Those seem like pretty important conditions. Given the information, determine the percentage of teams that have won 3 games, lost 1 game out of the first 4, and then have won the 5th. The first thing we can do is just completely cross this out, because these two cases are true, given that the teams have won 3 games and lost 1. It's already accounted for, so you don't even have to worry about the fact that they have won 3 games and lost 1 game. Now all we care about is how many teams have won the 5th game. Well, what do we know? We know that they overall win the series 80% of the time. And more specifically, they win the series 65% of the time when they lose the 5th game. So a key thing to realize in this problem is that B is actually a subcase of A, right? It's case 1 of A, because the percent of times they win after they lose the 5th game is included in the overall percentage of winning. Now, what do we do from here? Well, let's say X is the probability of winning the 5th game. We don't know what that is, so anytime you don't know what a variable is or what the value is, just make it variable. If you know that X is the probability that they win the 5th game, you can actually say 1 minus X is they lose the 5th game. The reason this is true is because, let's say, for example, right, we had let's say I told you there was a 30% chance of raining today. What is the percentage of it not raining today? Well, that would just be 100% minus the 30, right? So 70%. We take the complement, which is why this works. So now that we kind of know that, how can we write this case here as an algebraic statement? Well, it says they win the series 65 after they lose the 5th game. We know what the percentage of the losing 5th game is, right? It's 1 minus X. We already found that out. And when they lose, then they end up winning 65% of the time. So you can just multiply those two ones. Right. Now, that's case 1. What is another case here? Well, either they lose the 5th game and then win later, or they win right away, right? So case 2 is just they win right away. They win the 5th game. Well, we already know what that is. That's X, right? Because we found that out earlier. That's how we started the problem. We just labeled X the probability of winning the 5th game. Now that we have the two cases, what we can actually do is take this overarching kind of case here of winning 80% of the time, right? So for basically, you have total probability equals case 1 plus case 2. Now, the reason why you don't multiply the two cases is because they're mutually exclusive. That's a fancy way of saying that these cases can't occur at the same time, right? So case 1, for example, is either you lose the 5th game or you end up winning later, and case 2 is that you win right away. You can't win and lose at the same time. Therefore, you have to add these two different cases. Now, what is the total probability? Well, they give us 80%. What is case 1? Well, case 1 here is just going to be 1 minus x times 65% plus the case 2, which is x. Again, now we can solve this, and you should get 3/7. And if you put that in percentage form, you have to multiply by 100, which will give you 43% as your answer. So basically how I did this problem. I hope you enjoyed, right? This is my first video, and I'll see you next time.